Suppose you have a drawer containing socks of 3 different colors. And so the question is, how many socks must you pick to guarantee at least 4 socks of the same color? So let's see how to think about this. So if we want to avoid getting 4 socks of the same color, then we should essentially be spreading the socks out among the colors as evenly as possible. So suppose the 3 colors, so suppose socks are either red, blue, or green. And so if we want to spread them out as much as possible, if we have here how many red socks plus how many blue we pick plus how many green. So the worst, or I guess for us, the worst case of trying to get the socks is that you get 3 red sockses. Let's say you start picking out the socks and you get 3 of them, and then you don't get 4, you then get 3 blue sockses, and then you get 3 green sockses. So a total of 9 sockses, and you don't have 4 of any of the same color. Now clearly, if you pick one more, it has to, so that one has to go to one of these groups, red, blue, or green. So you're gonna have to have a one of the colors before. And so that means the answer to this question is equal to 10 socks. So if you pick 10 socks, then you're guaranteed to have at least 4 of them of the same color. And so this is the idea behind the generalized pigeonhole principle. And what it says is that if you have n objects that are placed into k boxes, then at least one object must contain n over k ceiling objects. So what is ceiling here? So this ceiling function, so if you have, let's say, a non-integer here, a real number, and you take the ceiling, this would just be rounding it up, right? So the reason you need to do this is because maybe k does not divide n, and this needs to be an integer, so it's the ceiling, right? Okay, now the reason for this, so the reason for the generalized pigeonhole principle is that n over k is the average number of objects per box. So it's the average of objects per box. And so the idea is that if every box had less than this rounded up number, then there would not be enough room for all n objects. So at least one object has to reach the average rounded up. So in the socks example, we had 10 socks and 3 colors. So the average was 10 divided by 3 equal to 3.333 and so on. Now, a color cannot appear 3.33333 times, which means that one of them has to be larger than this, which means that at least one color has to appear 10 over 3 ceiling, which is equal to 4. And so this is the generalized pigeonhole principle. And so the idea is if you distribute n objects among k boxes, then some box must contain at least the average number of objects rounded up.